Question 7. So this says solve for x between 0 and pi over 2 for sine x equals sec x. So let's write that down in terms of what it actually means. So part 1, we've got 4 sine x equals sec, which is 1 over cos x. Well, if we multiply by cos x, that gives 4 sine x cos x equals 1. And it looks like we've hit a brick wall because we've got a mixture of sines and coses there. However, if you know your trig identities, which you ought to, you know that sine 2x equals 2 sine x cos x. So 4 sine x cos x is double that. So 2 sine 2x is equal to 1. Brilliant. So now we can do it. So now we've got sine of 2x equals 1/2. And we can see that this here is the domain in which we want the answers. But we've actually got 2x in the bracket. So we need to change the range in which we want the answers. So we double everything. We get that there. So we're now looking for answers between 0 and pi. Right, so if we arc sine both sides, we get 2x equals an arc sine of 1/2 is 6 pi. So 2x equals 1/6 pi. And just drawing the graph roughly between 0 and pi. 6th pi is there. So that one's pi, take a 6th pi, 5/6 pi. Therefore, x is equal to 1/12 pi and 5/12 pi. And that's the first part done. So now for the next part, let's just put it there to remind ourselves of what it was, so we can see it on the screen. So it says solve for theta between 0 and 360, that equation there. 5 sine theta minus 5 cos theta equals 2, giving your answer to 1 decimal place. Well, actually this one, bit more difficult, but the key here is to recognise that these two terms here, 5 sine theta take 5 cos theta, can be combined into the form r sine of theta take alpha. So if we expand this using the identities in your formula book, you get r sine theta cos alpha take r sine alpha cos theta. And if we compare this now to what's written here, I can see attached to the sine theta is a 5. So attached to the sine theta there is r cos alpha. That tells me that for these two expressions to be equivalent, that r cos alpha has to equal 5. So r cos alpha equals 5. Here, attached to the cos theta, we've got r sine alpha. Here, attached to the cos theta, we've got 5. Now notice that the minus signs match, so we don't need to consider them. So that tells us that r sine alpha equals 5. So let's call that equation A, that one equation B. So now, if we do equation B divided by equation A, so if we divide the left hand sides, we get r sine theta over r cos theta. That just makes tan, not theta, alpha, sorry. So tan alpha equals 5 over 5, which is 1. So that means that alpha is the arctan of 1, which we need to do in degrees. The question now is about degrees, so we'll put that there. So arctan of alpha, arctan of 1 is 45. So alpha equals 45 degrees. We've then got to find the constant at the front. Well, we do that by using Pythagoras on these two numbers here. I've done a video in depth on the proof behind this, but we're just taking for granted that you understand how to do it here. So r equals the square root of 5 squared plus 5 squared equals root 50 equals root 25 root 2 equals 5 root 2. Therefore, we can change this equation here to 5 root 2 sine of theta minus 45 degrees equals 2. So solving that now, well, first of all, we'll divide both sides by 5 root 2 to get sine of theta minus 45 degrees equals, and we've got 2 over 5 root 2, which hopefully the calculator will simplify for us. It does, root 2 over 5. So if we arc sine both sides, we get theta minus 45 equals arc sine of root 2 over 5 which is equal to, syntax error, delete one of those brackets, there we go, 16.4299. Right, so we've got one solution. Now let's have a look back at the range that we need the answers in, 0 to 360. However, we've just worked out for theta minus 45, so we need to take 45 from all the answers. So take 45 from 0, we get minus 45. Less than or equal to, let's just check that the inequality was right. Yeah, this first one's less than or equal to, then it's a less than. So less than or equal to theta minus 45. Less than or equal to, and take 45 away from 360, you get 315. So that's the range in which we're looking for the answers now. So drawing the graph. So we'll draw a little bit more than we need. So there's 0 to 360, but we only need up to 315. Let's go to minus 90 on that side. So 16.4299, we can see that actually extending the domain had no effect. So there we go, two answers. So we've got one at 16.4299, and the other answer, if we use this as the line of symmetry, is 16.4299 to the left of 180. So 180, take away that, is 163.5701. Just double check that. Yes, 163.5701. Right, so adding 45 to those now, so therefore theta equals, so add 45 to that, we get 208. Does it ask for any number of significant figures? One decimal place it asked for, so we must give it that in the answer. So 208.6. Then adding 45 to the other answer, we get 61.4. So there's our two answers. So put a box around the answer, and we're done on that question. Now this one was actually quite a tough question because it really involved you knowing your trig identities inside out. So what you should do in order to get better at this is to have a look at the exam questions I've done on all the trig identities. You can find that on the website, a11mathsrevision.com, but do have a go at them. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to a11mathsrevision.com.